webinar from Rockflow Dynamics. My name is Joanne from the RFD Aberdeen team, and today I'm hosting with Alexi, who will be our presenter, and then we also have Mike to help us with the Q&A. So this is the second part of our new energy webinar series. If you missed last week's webinar on geothermal modelling, you can find that on our YouTube channel. So today we are moving on to look at how you can use integrated asset modelling workflows in tNavigator to optimise your CCS projects. So Alexi will be demonstrating how you can incorporate all elements of the field from the reservoir, wells, PVT and surface network into one project and carry out all of your calculations in the same system of equations in a fully implicit way. So just to let you know that we do have a large number of attendees on today, so if you have any questions then you can pop these into the chat pane on the control panel on the side of your screen, and we'll answer as many as we can at the end. But if we don't have time to address your question live, we will follow up with you on email. And the webinar is being recorded as well, so we'll get that uploaded to our YouTube channel later today. And of course, if you have any further questions, you can contact us on our email there, or just drop the email to myself and I'll pass it on to the right person. So now I will pass you on to Alexi to begin the webinar.
Thank you. Hello everyone, my name is Alexi and I'm working as production engineer at Rockflow Dynamics based in Aberdeen. And today we are going to discuss one of the hottest topic in the last few years, which is CCS and sea carbon capture storage and CO2 injection into the reservoir. We'll go, as John already mentioned, so we will go through the key components of CCS projects, starting from surface, PVT, wells, and integrated with the reservoir model. But in the beginning, I would like to briefly mention why we should use CCS storages and why these projects are quite crucial for now. So on the left-hand side, you can see the graph which demonstrates a dramatic increase of CO2 emission. And on the right-hand side, so there is presented the current dynamic of the projects for CO2 storages. And so basically, there is a lot of topics and a lot of discussion regarding to the CO2 emission and how it affects temperature changes on the climate and how it affects acidity of the ocean. So therefore, it's quite hot topic now, and there is more and more projects which will be used to keep the CO2 into the reservoir. So going further, just to mention briefly the key aspects of CCS processing. So it can be divided into 3 stages. The first one is a capture of produced CO2. So the CO2 can be stored and captured from the plant, so from the mining. And after that, it should be transferred and compressed and transferred to a depleted reservoir or to the storage. And there is a lot of different aspects in each stage of this process. And today we will try to talk about the second and the third stages, about transportation and storage. And yeah, I'm just going a bit further. So I would like also to mention briefly four key trapping mechanisms. So the first one is structural trapping, when the free movement of the buoyant CO2 and CO2 trapped by the cap rock. So the second one is residual trapping, when the CO2 trapped in the pores due to capillary pressure. And the next one is solubility trapping, when CO2 dissolves into saline brine. And the next one is a mineral trapping, which takes much more time. And at this stage, trapped CO2 reacts with the rock and reacts with surrounding rock and mineralized. But at different stages, and they all can be modeled into tNavigator as well. So going to the integration and discuss why integration is important. So First of all, CO2 is quite sensitive to pressure and temperature conditions, so therefore we can obviously run the simulation model standalone. So however, we need to understand the pressure and temperature conditions, capacity of surface facilities, and CO2 performance within the pipelines and CO2 performance along the wellbore. So we also need to take into account the PVT properties as well. So therefore, we'll talk about all the components today. So we can obviously start with the subsurface, and we have geomechanics incorporated in tNavigator as well to check rock integrity during the CO2 storages. We will talk about well performance and how can we model injectors with the CO2, surface network, and pipelines and CO2 performance within the pipelines, and PVT. But I will be focused today mostly on production engineering side, starting from surface network, wells, and PVT. So just talking about the key aspects and key challenges. So first of all, CO2 is quite sensitive to pressure and temperature conditions, as I said before, and we usually consider that the CO2 should be injected at the supercritical phase at specific pressure and temperature. So, and usually talking about the CO2 storages, we consider depleted reservoirs with pretty low pressure and temperature conditions. So therefore, we are going to expect movement from CO2 from the gas, from the supercritical phase to the gas phase. So because of these changes, so we might expect in the industry different challenges such as hydrates formation, changes on ejectivity, salt precipitation on the wellbore. So, and we also have some uncertainty in existing equation of state, which describes CO2 supercritical state with some level of uncertainty. So, but ideally, the key message from integration with the surface and wells, that we, as engineers, we need to understand CO2 performance starting from the source of CO2 and going to the wellbore. So we need to understand how the temperature and pressure changes and how can it affect the further process of, and how injected CO2 will migrate within the reservoir. So therefore, we need to understand changes in CO2. So, and for these purposes, we can use integration with the network. We can create a network model from scratch in tNavigator, and we can specify rates limitation or pressure limits that we have on our surface level, such as auto pressure of compressor, or we can model compressor as well. We can specify capacity of compressor, and after that we can add more constraints related to the injection rates on different levels of the model. So we can calculate pressure and temperature changes along the pipelines and understand some hydrates issues as well. So we can identify pressure and temperature conditions for hydrates formation, because it's probably will be quite difficult to remove all water content from injected fluid. So we are expecting to see some even little portion of water within the CO2. So therefore, this functionality is quite useful. So, and also we can specify the PVT model, and we can specify impurities and water content in compositional model. So going further to the PVT, so we have a variety of different equation of state which might be used to describe PVT properties of CO2. So however, most of them, they have some uncertainty in density calculations. So however, we have few developments further, and we'll implement soon free energy equation. So however, we have a few more projects, and we can use existing equation of states to describe the PVT properties of CO2 and impurities as well. So basically, the PVT is quite important for carbon capture storage projects, and PVT uncertainty might affect the quality of the model, and they might affect further results. So therefore, it should be checked. And yeah, just going to the next step. So we started to talk with the surface network, PVT, and we also need to understand how one of the key aspects is CO2 performance along the wellbore, because we might have the biggest pressure drop and the biggest temperature drop along the wellbore. So therefore, we might have some uncertainty on wellbore level. So therefore, we can generate and we can create injector models in tNavigator. So we can incorporate it with the PVT models, and we can connect injectors with the surface network. And after that, we can do the QC of VFP models. We have a list of multi-place log correlations, and we can also use them to validate the data and select the best way to model in CO2 injector and analyze wellbore performance and fluid performance along the wellbore as well. So we can also connect well projects with a subsurface model implicitly. So we can specify the perforations and connect our wells, our CO2 injectors with the reservoir model. Yeah, going further. So just talking about the integration. So we already discussed the key reasons why we need to connect all these modules. So, and we have a lot of flexibility to do it. So basically, we have a subsurface model with connected well models, and we can specify well rates or amount of CO2 we can inject. We can calculate the pressure drop associated with the surface facility and check the capacity of injection system. And we can specify the logic and specify how much CO2 we need to inject and how can we distribute it between the wells. And yeah, just to summarize the workflow, as I said, we can start with the PVT model at the beginning. So we have different options to simulate CO2 supercritical CO2, or just to simulate CO2 properties using variety of equations. So after that, we can connect PVT models with the injectors. We can specify injector models, and after that, going to the surface facilities and subsurface model, we can integrate it. And after that, engineers can run variety of cases, variety of strategies, and understand the potential of the project and how can we control CO2 injection and how can we distribute injection rates between the wells or in the field. So finally, going to the few last slides. So as I said before, we have in our approach, so as I said, we have a proper integration between the subsurface and the wells. So we can specify the well perforations in the well designer, and we can integrate the reservoir model, and we don't need to apply any additional controllers to run integrated model. So we can basically control CO2 injection from the surface level and control it using by the pressure and rate constraints on the surface level to run the model. And last slide, I just want to show you. Okay, can I apply it? Click next. Yeah, so I just want to show you how the integrated project looks like. So we have integration with, as I said, we have integration between the subsurface model and the network. So as you can see on the right-hand side, we can work with our connected surface network model with the connected well projects and pipelines. So we can specify boundary conditions such as pressure or rates depending on the field or depending on the project. So we can also add boosting. We can specify compressor performance if we need, so to add additional pressure drop in the surface level. And all these projects are connected with the subsurface model. So therefore we can run the model. And in this case, our project controlled by the network. So we can see the results on the right-hand side. We can see the pressure and temperature distribution, and we can see how much gas, how much CO2 was injected and how it affects the reservoir performance. So basically we can apply a variety of cases. We can simply work with the different options for the network. You can change your network model, or you can change your PVT or well performance and rerun the model and see how it will affect. So this integration helps us to understand the proper performance of the project and understand and reduce any uncertainties on each level. So yeah, which is quite important for a CCS project, I think. So I think this is all from my side. So if you have any questions, or if you're interested to ask more details regarding to the CCS projects and the integration in tNavigator, so I will be happy to answer. Thank you.
Let's go to the next slide. You, Alexei. So I think Mike is going to help us out with some questions. If we just have a look at what we've got coming in.
Indeed. So Alexei, we have a few questions. What is the best equation of state to describe CO2 density changes in supercritical conditions?
So that's a good question. So probably one of the key questions for such projects. So there is few more equations currently in the industry, like a three-phase equation which describes the density in the best manner. So however, even existing equations such as Penck-Robertson, so already is good enough at specific pressure and temperature conditions. So they have some uncertainty at low temperatures, as I remember. So, but I can't name exactly equation of state. Maybe some of Span and Water probably maybe one of the best equation.
Can you explicitly model hydrates and salt precipitation in the wellbore?
So for now, I need to double check. Do we have such functionality? So, but I think we can do. So we can understand hydrates formation on the surface level. So we can understand pressure and temperature for hydrates formation. So, however, we can do some workaround. So we can, because we have a connected PVT model, we can have a look on the phase diagram and we can understand. We can calculate temperature and pressure on the wellbore, and after that we will be able to understand is there any conditions for hydrates formation, for instance.
Can you reproduce salting out effect in tNavigator? I guess it's quite a similar question.
I need to double check with my colleagues with reservoir engineers. So, but as I remember, we can do it. Yeah.
Can you include the reservoir rock composition and define geochemistry reactions?
Yes, we can do. Yeah.
And we have one here. How does this link with geomechanics modeling from a workflow point of view?
Yes, so it's basically we have implicit connection with the geomechanics. So we can run both models simultaneously. We can run geomechanics and reservoir model. We can run both of the models implicitly, and it also can be connected with the surface network. So we can basically run all these modules implicitly.
Do you model Joule-Thomson cooling for injection into depleted fields?
Yes, so we can do it. So we have some keywords which describes temperature drop because of the gas expansion.
Yeah. And we'll go for one last question due to time. Can we, how do we model the injectivity profile for each well?
So basically, the injectivity profile of the well will be characterized by the reservoir performance. So we have, because we integrated with the subsurface model. So however, we have few more options. So we can, it depends on the objective. So we can describe injectivity using the IPR model. So, or obviously for the forecasting, the injectivity will be characterized by the reservoir performance, by the reservoir model.
Okay. Cool. Sorry. Yeah, as Mike said, I think we'll wrap it up there this week. We do have some more questions that haven't been answered, but we will make sure that we get in touch with you, and anything that was like unsure as well, we can double check it and get in touch. So yes, please come back next week and join us for the last webinar of the series. So it's going to be hosted by our colleague Serkan, and he is going to be looking again at CCS, just about more of the tools that we've got in tNavigator to help with your projects there. So thank you everyone, have a great day, and we look forward to seeing you next week. Thank you.
Thank you.
Thank you.